Um, Hello everyone, good evening. So here we shall solve some more KCET previous year questions on the chapter hydrocarbons. So any doubts if you have in any steps, then please write that in the comments section. We shall obviously clarify them, and and please install our Sapience Education application also, where we shall upload some important questions based on the previous year KCET exam. So here it is told that the reagent X used for the following reaction is, here an alkyne is reacting with hydrogen in the presence of the reagent X to produce a cis alkene. So here a cis alkene is formed. So cis alkene is obtained, as we know, if we use uh, palladium with carbon. So it means the reagent X would be PDC. Option B is the correct answer. Then here it is told that N-propyl chloride, which is N-propyl N-propyl chloride, which is like this N-propyl chloride, which is CH3, CH2, CH2Cl. So this N-propyl chloride, it reacts with so, sodium metal in the presence of dry ether to give. So here um, it means that 2 moles of this alkyl chloride will react with 2 moles of so, so, sodium, and it will form 2 NaCl, and it will form CH3, CH2, 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 and CH3. Okay. So it means that it will form 1, 2, 3, 4, 5, 6. So it will form N-hexane. N-hexane will be formed. So option A is the correct answer. Then it is told the alkyl halides required to prepare this alkane by Wood's reaction. So it has to form this alkane by Wood's re reaction. So Wood's reaction is um, so it means here some alkyl chloride should react with another alkyl chloride in the presence of sodium and dry ether, which is called the Wood's reaction, to form an alkane R R dash and 2 NaCl. So here it means that here there should be Cl, and this, okay. So then Cl, that should react in the presence of sodium and dry ether to form this alkane. Or it can be we can also react mm, isopropyl chloride isopropyl chloride with this one, this Cl. Then also it will form this alkene, okay, and plus 2 NaCl, obviously. So here option C is the correct answer. Then it is told 2 butane 2 butane is reduced to to transbutene transbutene using 2 butane. So it is like this, 2 butane. So that is reduced to transbutene, means this is 2 butane and this is transbutene. This will be formed. So as you know that if trans isomer is formed, then sodium with liquid ammonia should be used. Sodium with liquid ammonia should be used. Then only it will give trans alkenes. Trans alkenes will be formed from alkynes. If I use sodium with liquid ammonia, which is also called as Birch reduction, which is called Birch reduction. Okay, so it means that option B is the correct answer. Then it is said that identify X in the following reaction. So here the C6H6, that is benzene. Benzene will react with 6 moles of chlorine, which is in excess, in the presence of anhydrous aluminum chloride in dark and cold environment to form the product X plus 6HCl. So it will form, obviously it will form hexachlorobenzene. Hexachlorobenzene will be formed, which is Cl, Cl, which is also its its molecular formula is C6Cl6. So it is the product X. So it means that option A is the correct answer. And here it is told arrange benzene, N-hexane and ethyne in decreasing order of their acidic behavior. So the rule is that when the percentage S character, when the percentage S character of the carbon increases, then the a- acidic nature also will increase. When the percentage S character of carbon increases, then the acidic nature will also increase. Acidic nature will also increase. So, so in case of ethyne, which is CH, C2H2 actually, C2H2, which is CH triple bond CH. So here carbon is sp hybridized, sp hybridized. So here the percentage S character is 50%. And in case of n-hexane, which is CH6, CH3, CH2 whole 4, CH3. So here carbon is sp3 hybridized. So here the percentage S character is obviously 25%. And in case of benzene, in case of benzene, which is C6H6, here as we know that the carbon is sp2 hybridized. Since here we have got uh, here each carbon is linked with three surrounding atoms. So here carbon is sp2 hybridized. So here the percentage S character is uh, one third, that is 33.33%. So obviously ethyne is the most acidic and n-hexane is the least acidic. So therefore the the decreasing order, therefore the decreasing order of the acidic behavior, decreasing order of the acidic behavior is one is ethyne more than benzene more than n-hexane. Ethyne more than benzene more than n-hexane. So option D is the correct answer. Then here it is told peroxide effect is observed with the addition of HBr, but not in the addition of but not with the addition of HI to unsymmetrical alkene, because so the reason is that in case of hydrogen i- iodide, the hydrogen and iodine covalent bond, the hydrogen iodine covalent bond is weaker than the hydrogen and bromine covalent bond. So in case of HBr, the HBr covalent bond is slightly more stronger than the covalent bond in HI. So in case of HI, here hydrogen free radical and iodine free radicals are easily formed, and in HBr the free radicals are not formed, and in case of HI free radicals are formed, free radicals are formed and so here two iodine free radicals can combine to form iodine m- molecule. So here the option A is saying that HI bond is stronger than HBr and is not cleaved by the free radical, which is wrong. B option tells that HI bond is weaker than HBr bond, so that iodine free radicals can combine to form iodine m- molecules. Then option C is saying that the bond strength of HI and HBr are same, but free radicals are formed in HBr. The bond strength of HI and HBr are same, but okay, so their bond strength is not same. Since the bond enthalpy, the bond enthalpy for HI bond, it is approximately 300 kilojoule per mole, and the bond enthalpy of HBr bond is slightly higher, which is nearly 364 kilojoule per mole. So obviously, since the bond enthalpy of HBr is higher than that of HI, so HBr bond is more stronger. Here the it means the bond strength is is higher for HBr than that of HI. So it means that option B is the correct answer. Then here it is saying that identify A and B in the reaction. Here propene, which is CH3CH2, that reacts with HBr, to form benzoyl peroxide. It reacts with benzoyl peroxide. It means that it here propene, it reacts with HBr in the presence of benzoyl peroxide to form A as the major product. Form A as the major product, and it reacts with HI to form B as the major product. So then we have to identify the products A and B. So when peroxide is used, then as we know, here we have to use the anti-Markovnikov's rule. We have to use the anti-Markovnikov's rule. Since why here the reaction will proceed through free radical mechanism. Through free radical mechanism, it will proceed. And when HI will react with propene, and here peroxide is not used also, then here the Markovnikov's rule should be used. Markovnikov's rule should be used to find the major product. So, so when Markovnikov's rule is used here the reaction will pro pro proceed through the formation of the carbocation. So here the more stable carbocation should be formed. More stable carbocation is formed as the reaction intermediate. But here, when anti-Markovnikov's rule is used, here the more stable free radical will be formed. Okay. So when HI is reacting, CH2, it is reacting with HI, then here the heterolytic bond cleavage will be formed. So then here the carbocation will be formed here, and this hydrogen will be linked with this. So here, since here it is a 2-degree carbocation, 2-degree carbocation, it is more stable, more stable. So it means this I minus now it can attack here, and then it will form CH3CHI CH3. So it is the major product which is the compound B which is formed. So isopropyl iodide should be formed as the major product B here. Since here if the carbocation is formed, let's say here, then here it will be a 1-degree carbocation. It is a 1-degree carbocation, so it is less stable. So from here, a minor product will be formed as per the Markovnikov's rule. The minor product which will be formed is the N-propyl iodide. which is the minor. And in the case of the option A, here the no in the product A, it is the propene. Propene is reacting with HBr in the presence of benzoyl peroxide. So here the free radical will be formed, and here H free radical and bromine free radical will be formed. Then here the CH3, CH2, then CH2Br, it will be the major product which will be formed, which is according to the anti-Markovnikov's rule. So it means it is the major product A. So the product A is N-propyl bromide, and the product B is isopropyl iodide. Isopropyl iodide. So it means that option D is the correct answer. So hope all of you understood the solutions of all these questions based on the previous year KCET exam on the chapter hydrocarbons. So still any doubts if you have, then please write that in the comments. We shall obviously clarify them. And please install our Sapience Education application also, where we shall upload some important homework questions based on the previous year KCET exam, which shall be obviously helpful for your exam. So thank you everyone. Bye.